So this is the question. Prove that. Let's do it quick. Prove that y is equals to. Let me know. Have we done this question? If we have done, then I'll be leaving it. Have we done?
No, ma'am, I don't think so.
Okay, we have not done. Let's do it. Okay. So we have to show that this is an increasing function of theta in 0 to pi by 2. So basically in this interval it is increasing. This is what we have to prove over here. Let's try proving it. So at first what we'll be doing over here, Fatima?
We'll find f dash x.
F plus x. What will be f dash x?
4 cos theta into the minus sin theta. Oh,
Is it so?
yes.
Question we'll be using over here, right?
Yes.
Okay. Please tell me what we'll be getting.
4 sin theta into minus sin theta divided by 2 plus cos theta whole squared.
Yes.
Minus 1.
Yes. Okay. Let's try simplifying it. We'll be having 8 cos theta
Yes.
plus 4 cos square theta. Is it so? Plus 4 sin square theta, right? Fatima?
Yes.
2 plus cos theta whole square minus 1. Let's simplify it more. What will be having? Can you tell me? Are you getting anything from these two terms?
So
Does it
8
looks
cos
like
theta plus 4.
8 cos theta plus 4 by 2 plus cos theta whole square minus 1. Now still we need to do the simplification over here, right?
Yes.
Okay, let's do it. So if we'll be taking the LCM, 2 plus cos theta, okay, that will square. Now we'll be having in the numerator. Can you tell me?
8 cos theta plus 4 minus 2 plus cos theta whole squared.
So simplification over here. So we will be having 8 cos theta plus 4, okay, minus a square. Let's open the bracket, okay. Let's open directly. So a square, that means 4. Then b square will also be there. That means minus cos square theta, right?
Yes.
And then plus b will be there. That will also become negative. That means minus 4 cos theta. Is it so, Fatima?
Yes.
For 1. What else?
8 cos theta minus 4 cos theta.
Minus cos square theta. 8 minus 4 directly also we can do. 8 minus 4 will be 4, right?
Yes.
So 4 cos theta minus cos square theta, okay, over 2 plus cos theta. That's square. Now can take cos theta common from the numerator. We can take cos common from the numerator, and we will be having 4 minus cos theta. Okay, over 2 plus cos theta whole square. Now we have to show that it is increasing function. You can understand that if you will be taking f dash theta is equals to 0, will it be possible to take out theta from here? Maybe or may
No?
not be, but it will not be that simple. That you are understanding?
Yes.
Okay, so getting critical point, maybe it will be little bit tricky over here. What we can think over here, what is the interval 0 to pi by 2? Now we will think that whatever we'll be taking as a theta in between 0 to pi by 2, okay, the denominator is whole square, that will be positive, right?
Yes.
Denominator will always be positive, okay, because theta is in between 0 to pi by 2. You can understand cos will give only the positive result, and
Yes.
even if cos would have given the negative result, still square, we would have thought about, since the square is there it will be positive, but here we will not be getting negative. Okay, so this
Yes.
cos will not generate negative in between 0 to pi by 2, right?
Yes.
So this will be positive, this will be positive. Now the confusion is whether this will be positive in this interval 0 to pi by 2, because cos will be positive, but 4 minus cos we are having. Okay, 4 minus cos we are having. We will say that when theta lies between 0 to pi by 2, we understand cos theta lies between cos 0 is 0 and cos pi by 2 is 1. Cos theta lies between 0 to 1, right?
Yes.
What about 4 minus cos theta? Cos theta is positive, we can see from here. But what about this 4 minus cos theta? So let's use the concept of inequality. At first, we'll be making it minus cos theta because 4 minus cos we are having. So at first, let's make minus cos theta over here. If we'll be making minus cos theta over here, we'll be multiplying minus 1, minus 1, minus 1 in all the parts. Then the sign will get reversed. Do you know that, Fatima?
Yes.
Okay, so this will still be 0, this will be minus 1, getting it?
Yes.
Okay, because we are multiplying minus 1 in all the parts. Okay, now 4 minus cos theta, that means we'll be adding 4 over here, we'll be adding 4 over here. Okay, we will be adding 4 over here, getting it?
Yes.
Okay, so that means 4, just 4, 4 minus cos theta, okay, bigger than 4 minus 1, that is 3. So we can say this is also positive. It is lying in between 3 and 4. Yes or no? Greater
Yes.
than 3 and lesser than 4. We can also write it like this. 4 minus cos theta is bigger than 3 and is smaller than 4. That means it will, this 4 minus cos theta is generating the positive result, right?
Yes.
In between 0 to pi by 2. That means if everything is generating positive result, this is also generating positive. That means this f dash theta is greater than 0 in this interval, right?
Yes.
Hence increasing, getting it?
Yes.
Okay, any confusion so far, Fatima?
No.
Let's do few more questions. Prove that logarithmic function is increasing on 0 to infinity. Okay, we have to show that logarithmic function is increasing function. Okay, in this interval, let's think about it. What is logarithmic function? Can we write f of x is equals to log x? That's what the meaning of log. logarithmic function is, right?
Yes, ma'am.
Okay, now f dash x. What will be f dash x, Fatima?
1 by x.
1 by x. Okay. Now the basic approach which we use for checking whether it is increasing, decreasing, we try finding the critical point. But here will it be possible?
No.
Yes. 1 by x is equals to 0 doesn't make sense. Okay. Whatever you will be taking the value of x, it will not generate the result as a 0. So critical point we will not be getting. You getting it?
Yes.
Okay. Now then we will start thinking. Then what? Basically, we have to we must get that f dash x bigger than 0. Then only we can say increasing. Okay, that understanding we are having. Now x must lie in which range? Previously theta was lying in between 0 to pi by 2. And we just started from there that theta lies between 0 to pi by 2. And from there we just started connecting. Here I'm going to say that x lies between 0 to infinity, right?
Yes.
Okay. So if x is bigger than 0, if x is bigger than 0, can we say that 1 by x will also be bigger than 0?
Yes.
Can we say that?
Yes.
Mathematically, logically, it is true. If x is larger than 0, whatever we'll be taking as a x, if that is larger than 0, so if we will be doing the reciprocal of that, it still will be bigger than 0. If we are taking x as a 2, 1 by 2, yes, it is bigger than 0. It can be closer to 0, but more than 0 we will be having, right?
Yes.
Okay, so 1 by x is also bigger than 0. Now 1 by x means f dash x. Is it so? 1 by x means f dash x. That is bigger than 0. Yes. Hence, this is increasing function. Can we declare from here, Fatima?
Yes.
Confusion? Any confusion?
I know, ma'am.
Let's move. Prove that function f of x is equals to x square minus x plus 1 is either strictly increasing, decreasing, 1 minus 1 to n. This one you are going to do, Father. Please do it and tell me what are you getting.
Yes, ma'am.
Are you getting it?
Yes, ma'am. If f of x is decreasing in -1 to 1 by 2 and increasing in 1 by 2 to 1.
Okay, it is decreasing in -1 to 1 by 2 and increasing in 1 by 2 to 1. Okay, yeah. You have found that dash x, then you have found the critical point, and then there you have got.
Yes, ma'am.
Let's continue. Which of the following function are decreasing 0 to 5? Okay. Functions are given over. Why it is not going? Can you hear me?
Yes, ma'am.
Okay. Yeah. Now it's so cos x we are having. Again, it
Yes,
is. Yeah. So cos x we are having, and we have to check whether it is decreasing in this interval or. So f of x is cos x. Dash x will be finding, right, Fatima?
yes, ma'am.
Will be
Minus sin x.
minus sin x. Okay. Now minus sin x we are having. Our understanding says that from 0 to pi by 2, sine is positive, right?
Yes,
But we are having minus sign, so of course it is decreasing. Yes or no?
yes, ma'am.
Okay, next one. The statement you have to write in from 0 to 1 by 0 to pi by 2, sine is positive. Here we are having minus sign, hence it is a decreasing function. As x is smaller than 0, hence it is a decreasing function. Next. Okay, so which of the following function are decreasing? The first one is decreasing, right?
Yes, ma'am.
Next one. Cos 2x if we are having. So we will be taking f of x is cos 2x. Okay. Now f dash x, what will be f dash x?
Uh, minus sin 2x. Minus 2 sin 2x.
Minus 2 sine 2x. Okay. Now x lies between 0 to pi by 2. Okay. X lies between 0 to pi by 2. But here we are having 2x. Okay. So we'll be doing the multiplication only. 2x. Okay. 0 into 2. Okay. Pi by 2 into 2. So is it becoming 0? 2x lies between 0 to pi? Yes. Now you tell me, sine is positive in 0 to pi, or it can be negative also.
Is positive.
Is positive. Okay. In between 0 to pi, sine is positive. But here we are having minus, right?
Yes, ma'am.
So again, it is just following the previous criteria, right?
Yes, ma'am.
To the next one. We are also having cos 3x, okay, which will become minus 3 sine 3x, right, Fatima?
Yes, ma'am.
Now x lies between 0 to pi by 2. So 3x 0 to 3 pi by 2, right?
Yes, ma'am.
Now in between 0 to 3 pi by 2, sine is positive or negative?
Mm, it's both.
Okay. we know that from 0 to pi, sign is positive. But from pi to 3 pi by 2, it is negative. So neither positive nor neither neither increasing nor decreasing, we can say, right?
Yes, ma'am.
Okay, next one. Tan x will be. F of x is tan x. Tan x will be
6 square x.
6 square x. Now x lies between 0 to pi by 2. This is positive. Sec is positive in 0 to pi by 2, right?
Yes, ma'am.
So it is increasing how much? Any confusion, Fatima?
No, ma'am.
Okay. So this is how we'll be dealing with this type of question. Now the question is like this: for which of the following intervals the function f given by of x is equals to x to the power 100 plus sin x minus 1 is decreasing. Okay, and the intervals are given. Intervals are given as 0 to 1, pi by 2 to pi. Okay, 0 to pi by 2. None of this. That means, are we going to check one by one for each interval? Because interval is important, right?
Yes, ma'am.
So one by one, are we going to check? Yes, we'll be checking one by one. Okay. So our f of x is given over here. Let's try finding f dash x. Can you tell me what will be f dash x?
99x raised to 99 plus cos x.
100x to the power 100x to the power 99.
Oh, yes.
And x to the power n minus 1. That is the formula, right? Fatima?
Yes.
Now sin x will be minus cos x, right? No, plus cos x. And 0, right?
Yes.
Now, in this interval, we are checking 0 to 1. Now you think about it. If we will try finding the critical point, it will not be possible, right?
Yes.
This power 99 and cos with angle. So we will try analyzing by ourselves. 0 to 1. In between 0 to 1, whatever x we will be taking, this part will be positive, right?
Yes.
Now what about this cos x? What can be done for this cos x? If I will plot the graph of this. Like this, the graph keeps on going. So can we say that if the angle is in between 0 to 1, will it be positive?
Yes.
Suppose we are taking cos x, cos 0 will. Okay, the answer will be 1, right?
Yes.
Okay, so at 0 we can see it's positive. Okay,
Yes.
whatever we'll be taking over here, it's going a lot. Can I leave and join? Let me try it. Like I can hear my voice.
Uh,
Let me try. Okay.
yes, ma'am.
Please don't leave. Just be here.
Yeah, yes, ma'am.
Can you hear me, Fatima?
Yes, ma'am.
Still it is. Okay, no worries. I'm continuing like this. I'm opening the white.
Yes.
So we were having 100 x to the power 99 plus cos x we were having, right? Can you
Yes, ma'am.
please for a while can you please pause it?
Yes, ma'am.
Can you please mute yourself for a while? I will check whether still it is. I suppose now it is
Uh,
good. Okay, Fatima, whenever you have to ask, you just unmute yourself. And
yes,
I'm
ma'am.
explaining. So x we are taking from 0 to 1. Okay. Now we can understand this part will be positive. Okay. Now what about cos x? So cos I have drawn the graph of the cos like this. Okay. And we also understand that cos is positive. Cos is positive in between 0 to pi by 2. Right? We say this pi by 2, this is in radian. If we have to convert it in degree, we say it is 90 degree. But if we will try writing it in form of number like 1 2 3 4, the number, not degree, not radian, number. So number means pi value. Pi means something around 3.14, right, Fatima?
Yes, ma'am.
Because we are not getting how to check cost. If it will be angle, great. If it will be radian, great. But here we are having just the normal number. Okay, 0 to 1 numbers we are having, not in radian, not in degree. So we are checking that pi by 2 means 3.14, and that by 2 when we will be doing, let's divide 3.14 by 2. We will be getting to 1 times 2. Okay, 1 decimal will be writing over here to 5 times 10 and to 7 times 40. So 1.57, right? Pi by 2 means 1.57, right, Fatima?
Yes, ma'am.
So we can say that in between 0 to pi by 2 cos is positive. That means from 0 to 1.57 cos is positive. Am I making sense?
Yes, ma'am.
So from 0 to 1.57, if cos is positive, then of course it will be positive in between 0 to 1, right?
Yes, ma'am.
If both are positive, then the function f dash x will be increasing in this interval 0 to 1. Getting it? Getting it? F dash x greater than 0, the function is increasing. Any confusion, Fatima? Are you understanding why we are changing the pi? How can we take pi as a all of sudden 3.14 or maybe 22 by 7? Are you getting it? Or you are having confusion? Yes? Can you hear me, Fatima? Can you hear me? Please let me know. Can you hear me? Yes, Fatima.
Yes, ma'am. Sorry, my screen was lagging for a second.
Okay. So, are you getting it? Why all of a sudden we are taking pi as a 22 by 7 or maybe 3.14?
Uh,
Actually, Fatima, pi is irrational number whose
yes, ma'am.
approximate value is 22 by 7, which we also call as a 3.14. Okay, pi is an irrational number which is non-terminating, non-repeating. But later on, we got to know that apart from degree, there is a unit of there is a unit for measuring angle, and that unit is called radian. Okay, and
Yes, ma'am.
it is that 2 pi radian is equals to 360 degree. From there we got to know in class 11 you must have learned that 2 pi
Yes,
radian
ma'am.
is equals to 360 degree. 2 pi in radian is same as is equivalent to 360 degree, but this is in radian. Still the value of pi, originally pi value is still 22 by 7 approximately, or 3.14 approximately in numbers. But when we are using this unit along with the pi, then it will be equivalent to 360 degree. We are not changing pi. Okay, so
Yes, ma'am.
are we, do we want to say that 2 into 22 by 7 or 2 into 3.14, that radian is 360 degree? Yes, we want
Yes,
to
ma'am.
say that 2 into 22 by 7 or 2 into 3.14 approximately that radian is 360 degree. If radian word you are not using, if this unit you are not using, then we cannot say it is equivalent to 360 degree. Getting it?
Yes, ma'am.
Okay, that's why when we are checking that what about the cos in between, cos x in between 0 to 1, where x is lying in between 0 to 1, so we realize cos 0 is 1. Great. Okay, x is lying in between 0 to 1. So how to check? Do we want to check cos 0 and cos 1? Yes. But how to check cos 1? So we are saying that we know that cos is positive in between 0 to pi by 2. And pi by 2 means, pi by 2 means, if we will convert it in like by taking pi as a 3.14, we are getting 1.57. That means in between 0 to 1, of course it will be positive because it is positive in between till from 0 to pi by 2, the cos is positive. That means from 0 to 1.57 cos is positive. Getting it?
Yes, ma'am.
Okay, so that's why we are declaring that it is positive. In this, for this is increasing function where f dash x positive positive. It is greater than 0 and f is increasing in the interval 0 to 1. Getting it, Fatima? Is it crystal
Yes,
clear now?
ma'am. Yes, ma'am.
Let's do the next one. Next intervals are also given over here, which is pi by 2 to pi. These numbers you will be able to check. We were having, let's check it now. 100x to the power 99 plus just cos x we were having or what? Just cos x, right? Yes, just cos x. 100x to the power 99 plus cos x. Okay, in this interval we have to check. Pi by 2 to pi. We can understand it's a positive numbers, right? So this will
Yes,
generate
ma'am.
positive result. And cos from pi by 2 to pi, cos will generate positive or negative. If we are
Negative?
talking, yes, okay, it will generate negative. Now the question is, one is plus, another is minus. If multiplication sign will be there in between, then we can declare it will be negative. But addition sign is here. Can you see? Plus sign is there.
Yes, ma'am.
So now also we are having the confusion that a positive number and then a negative number can be positive, can be negative also. Yes or no?
Yes, ma'am.
Okay. So we will be analyzing that which one is bigger. This 100x to the power 99 is bigger than cos x, then the result will be positive, because a positive number minus a like any number, the result can be positive. And if I will write minus 8, the result can be negative. Getting it, Fatima?
Yes, ma'am.
Okay, so we have to check whether the first part is bigger than the second one or not. Let's think about it. Pi by 2 to pi. What does it mean, pi by 2? Pi by 2 means, now only we have checked, it was something around 1.57, right?
Yes, ma'am.
Pi means what? Pi means 3.14. I was telling you, pi originally, pi is just a number. It's an irrational number. That value is 22.22 by 7 or 3.14 approximately. So 3.14. So x lying in between this two number, and that to the power 99. Think about it. 99. Will it be huge number?
Yes,
Yes or
ma'am.
no? So it will be bigger than cos x, because cos lies between -1 to 1 domain. We have learned that cos, the output of cos lies between -1 to +1, right?
Yes, ma'am.
So the first part is generating a huge result minus a little bit of like smaller any number. Still we'll be having positive answer. Yes or no?
Yes, ma'am.
Okay, this is all the thing you have to write it in the note. That since 100x to the power 99 is bigger than cos x, since 100, let me choose the, since 100x to the power 99 is bigger than cos x, then x lies between, what was that, pi by 2 to pi. Okay, okay. Therefore f dash x bigger than 0, hence it is increasing function. And we were checking decreasing, right? So till now option 1 and option 2 failed, right?
Yes, ma'am.
Now option 3. Option 3 we are having, we have to check in between 0 to pi by 2. Okay, in between 0 to pi by 2 we have to check, and still we are having f dash x as 100x to the power 99 plus cos x. Okay, let's think about it. If we will be taking 0 to pi by 2, of course it will be positive, of course, and of course it will be positive. So positive positive, of course the result will be bigger than 0. Yes or no? Here we don't
Yes,
even
ma'am.
have to think. Okay, and it is increasing. So the question, the instruction says that check in which interval the given function is decreasing. So whatever options are given, everywhere it is increasing. None of these will be the option B, where it is given that none of the option will be correct option. None of these is there. That option will be the correct option. Getting it, Fatima?
Yes, ma'am.
Any confusion?
No, ma'am.
Okay. Now the next one is for what value of A? For what value of A function I am writing f of x is equals to x square plus ax plus 1 is increasing. 1, this interval 1 to 2. Okay, in this interval, what shall we take as a value of A so that our function will be increasing? Okay, so the approach which we use for solving any question, the same approach we'll be using over here also. What we'll be doing, we will be finding f dash x over here. Our f dash x will be, Fatima,
2x plus 8.
x plus a. Now this f dash x must be greater than 0 in this interval 1 to 2, right?
Yes, ma'am.
Okay, so x lies in between, x lies in between 1 to 2. Okay, x lies in between 1 to 2, and we are having 2x plus a, which has to be bigger than 0. We don't know whether it is bigger than 0 or not. Okay, we wanna make it bigger than 0. Here we can write it bigger than 0 because a value we have to find. So we need to take this condition that yeah, it is increasing, and then we are finding a value, right?
Yes, ma'am.
So 2x plus a bigger than 0. If we will be taking x as a 1 in this condition, if we will be taking the end point 1, because 1 is also included, close interval is given, right, Fatima?
Yes, ma'am.
Okay, if we will be taking x as a 1, then let's see from here what are we going to get. Can you tell me what are we going to get, Fatima, if we will be taking x value as a 1?
2
2x plus
plus 8.
8, 2 plus 8 bigger than 0, right? It has to be bigger than 0, then we are finding the a value, right?
Yes, ma'am.
That means can we say that a must be bigger than minus 2?
Yes, ma'am.
If we will be taking the end point x equals to 2, then what will be getting, Fatima?
4 plus 8.
4 plus a, and that must be bigger than 0. That means a must be greater than minus 4, right?
Yes, ma'am.
If I will represent this inequality, which you have learned in previous class, the inequality chapter, that find the common solution. So if I will represent this inequality on the number line, let me represent a greater than minus 2. So somewhere minus 2 is there and a is bigger than that. Okay, a hollow circle and a is bigger than that. That means in this direction. Right, Fatima? Have you learned
Yes,
this in the previous class? Now the next
yes,
inequality, that a is bigger than minus 4. Let me choose different color. So a is bigger than, here maybe here we are having minus 4, and a is a hollow circle and a is bigger than minus 4, right?
yes.
Now can you tell me what will be the common solution, what will be the intersection, the common part? Can we say this is the common part, the common reason that both the part is indicating? Yes or no?
Yes,
Okay. If I will be drawing a same straight line rather than drawing two different lines, if I'll be plotting in the same line. So let me draw the way you must have learned in class 11. What we do, we draw a line like this and we say it is bigger than minus 2. And then we draw a line from this minus 4 and we say it is bigger than minus 4. Now can you see this, the common part? This is the common one. So the common solution of this 2 is a must be bigger than minus 2. Getting it?
Yes, ma'am.
Okay. So what will be the a value? We can say that a must be bigger than minus 2. Then and only then this function will be increasing in this interval. Are you getting it?
Yes, ma'am.
Okay, end point we have taken and we tried finding the common solution for a. Okay, and then this will be the condition which will give the function is the increase. Let's do the next one. It says that let I be any interval disjoint from this negative 1 to 1. Okay, prove that the function, prove that f given as, the function is given as 1x plus 1 by x is increasing on I. We need to understand it first. Okay, what does it says? It says that let I be any interval disjoint from this one. That means I is such an interval which must not contain this one. See, disjoint. Disjoint means it must not, it must be disjoint from here. There must not be any common element from here. Are you getting it? I is such
Yes,
an
ma'am.
interval. Okay, from negative infinity to positive infinity, I is such an interval we have to choose where minus 1 to 1 we cannot take. Okay, this must be disjoint. So we are we saying that we'll be taking the interval as a minus infinity to minus 1 open interval and then from 1 to infinity? Yes, this is, these two intervals are disjoint from this interval. Are you getting it?
Yes, ma'am.
Okay, in this two interval we have to check whether our function is increasing or decreasing. So you can understand one by one we'll be checking, but x plus 1 by x we are having. If we will be finding the derivative f dash x, what we'll be getting? X plus 1 by x will be, Fatima, 1 plus 1 plus
1
1
plus
minus,
1 minus 1 by x squared.
okay, which we can write as a x square minus 1 by x square, right, Fatima?
Yes.
Let's try finding the critical points. So the critical point, if we will try finding from here, is equals to 0. So the denominator we can shift to another side, it will get multiplied with 0. We'll be having x square minus 1 is equals to 0. Right, Fatima?
Yes, ma'am.
We can write it as a x plus 1, x minus 1 is equals to 0. So from here we are getting the critical point is a minus 1 plus 1, right?
Yes.
That means from negative infinity to positive infinity, these two are critical point. The disjoint which we wanted to exclude, these two are critical point and we just need to take a number in between minus infinity to minus 1. We have to check whether f dash x is positive or negative. We have to take a number from 1 to infinity and we have to check whether our f dash x is positive or negative, and accordingly we will declare, right?
Yes, ma'am.
And Any confusion? I'm leaving this one for you. Let me know
No,
any
ma'am.
confusion.
No, ma'am.
After this, I can see all the remaining question you will be able to do. Log of sin x, we are having the function increasing or decreasing. Okay, in between pi to whatever or 0 to pi by 2. You can understand. Log of sin x, we can use chain rule over here. Right, Fatima? You just tell me what will be act as x.
1 by sin x into cos x.
Yes. Basically, it is what x?
Yes.
It, it is cortex, and here the interval is also given. Okay, that check in this interval, check in that interval. So you just think about it, what is positive in this interval or not, or it is positive in, like whether it is positive or negative in the other interval. You just check it like that, in between 0 to pi by 2, or maybe in between, here it is given in between pi by 2 to pi. So you just apply the logic like this one. Okay. In first quadrant, all positive. In second quadrant, sine positive. In third quadrant, tan positive. And in fourth quadrant, cos positive. Only this logic will work. If I will be asking you in between 0 to pi by 2, you will say all are positive. All
Yes,
will
ma'am.
generate positive answer. In between pi by 2 to pi, only sine will generate positive answer. Okay, in between pi by 2 to pi, in between pi to 3 pi by 2, pi to 3 pi by 2, you understand that only tan and cot will generate positive answer, and remaining all will generate negative. Yes or no?
Yes.
Okay, so this, just the quadrant, this knowledge will help you analyzing that it will be increasing in which interval and decreasing in which interval. F dash x is equals to 0, we don't have to do. Getting it?
Yes, ma'am.
And the last question which I am writing over here is y is equals to x square e to the power minus x. When you will be finding y dash over here, let me write it quickly. Chain rule we have to use over here, Fatima. Okay, or no, not chain rule, product rule. Okay, first function, derivative of first function, then second function plus the derivative of second one. So 2x e to the power minus x plus x square and minus e to the power minus x. Any confusion, Fatima?
No, ma'am.
Okay, here you can see that e to the power minus x, we can take out common from both the part, and we will x also we can take out common. Okay. However, if I'm not taking x, I'm keeping x like this, 2x plus x square like this. Okay, and only e to the power, not plus, it is minus. Only e to the power minus x I have taken out common. Now you can understand that this, whatever x you are taking, okay, here the interval is also given. Let me take the interval. Okay, interval is not given, the options are there. It is increasing in which interval. Options are like this, from minus infinity to plus infinity. Option 2 is minus 2 to 0. Okay, option 3 is 2 to infinity, and option 4 is 0 to 2. Now our y dash is this one. Can we say that, Fatima, that whatever we will be taking x, this e to the power minus x will generate a positive answer? Can we say e is a number? Think about it. E is a number lying in between 2 to 3. Just like pi, e is also having its value. Okay, in between 2 and 3, there is a decimal number
Yes, ma'am.
for e. So suppose whatever 2 point whatever we are having for e value, whatever power you will be taking, x you will be taking a positive number or maybe a negative number. So suppose you are taking x as a minus 2 and you are checking here minus x is there. So minus of minus 2, our answer will be positive, right?
Yes, ma'am.
If you will be taking plus 2, okay, plus 2, then 2 point something to the power minus 2. This is the law of exponent we can use over here. We can say it will be 1 by 2 to the power whatever, 2 point whatever is there, that to the power 2. Can we say that, Fatima?
Yes.
So are you understanding? If the power is minus x, whatever x you will be taking, a decimal number, a positive number, a negative number, your final result for e to the power minus x will be positive. Getting it?
Yes, ma'am.
Okay, that's why we are keeping e to the power minus x aside. Okay, or we will be solving it for finding the critical point. We will be solving this one. Try it at your home. We will be solving this part for finding the critical point. Or you can say you will be taking everything and you will be writing is equals to 0. Okay, and this part, since it is a positive e is just a number. Okay, and whatever x will be there, it will be positive. So basically we need to find the critical point from here.